Young friends, you know our subject is manufacturing process. Manufacturing process is 2, which basically covers processes close to machining. I am A.B. Chattopadhyay, Professor of Mechanical Engineering, IIT Kharagpur, and my contact details are given in this plate. Now, you are presently students and after some time you will become engineers, but later on you will be very important part of the society and nation, and you have to contribute and take the responsibility to fulfill the national target. Every nation has got certain target. What is that target? It is common to all nations. Growth of national economy, that is the backbone of any nation. How it can be attained? Improvement of standard of living of the people of the nation. Now, standard of living, you know, is the index of progress and prosperity of civilization and nation. It has to be continuously improved. You see the standard of living of Japan, Germany, they are very advanced, progressive and prosperous countries compared to some African countries where standard of living is so poor. But another important target, especially for big countries like India having vast population, is creation of employments. Now, industries are a very important part of the country or nation. So, they have got enormous responsibility to fulfill the national target. To achieve it, to help that, they must have their own goals. What are the goals of the industries? Enhancement of productivity and quality of the products. Second, sale of the product. Whatever they produce, that must be sold, and they have to create the market, expand the market so that their products are sold. Then profit. Profit is a must, that has to be created for the continuous growth and benefit of the society. And this really leads to what is called competitiveness, which is essentially important, especially after globalization of competitiveness and all the standardization. Then expansion. Every industry should expand in their production and diversification of production, and this is the index of dynamism of the industries. Now, we often talk about production engineering and side by side manufacturing science and engineering. There are correlations, there are relations between production engineering and manufacturing. What is that? Let us see first what is production engineering. Production engineering deals with production of goods, solid goods like furnitures, houses, buildings, equipments, machineries and so on, and services like design, like plan, research, concepts, etc., by best utilization of the existing resources for men's material welfare, for welfare of the human being, briefly MMW. Now, what is really mean by these materials for men's welfare? Right from the history, if you see that most important material or object necessary for civilization or mankind is shelter, housing, then clothing, then medicine, then education, then transport. You see that Japan is the most prosperous and developed country in the world now. And how is this justified? The transport system of Japan is the best in the world now. Communication has changed the whole shape of the whole world. IT, information technology, what tremendous growth has taken place all over the world. And last but not the least, entertainment. Yes, we are human beings, we have got stomach to be filled, but we have got a mind also, and to satisfy and to please the mind and to keep ourselves alive and active, our entertainment is also necessary. So, all these things aiming improvement of standard of living. So, all these constituents are necessary for improving the overall standard of living. Now, how to create this men's material welfare? Where from this will come? This will come from the natural resource. First, what we need is natural resource. For example, say there is the very primitive days, say pre-Paleolithic age, people did not know use of agriculture or fire or anything. They found only some, say, natural fruits, say an apple tree. They went to the tree and found lot of ripe apples lying on the ground. They simply picked up and swallowed. When this was exhausted, the natural resource at the source exhausted, then they had to stretch their hand towards the branches and pluck the fruits from the trees. That is the beginning of what is called human effort. Now, after all the fruits nearby are exhausted and your hand cannot reach, then you take help of a stick or a branch of a tree and you shake it and you get the fruits falling, and that is called tools. That is the beginning of use of tools. Now, come to reality. Natural resource really means, say, the wind or air, without which nothing can survive, then water, heat and light through sun, then plants and vegetables, and finally minerals, both liquid and solid. Now, human effort also includes the animal force, animal power. Then what we mean by tools? It is not really hand tool. By tool here we indicate say power plants, steel plants, chemical plants, factories, machine tools, and so on. Now, let us come to manufacturing. What is meant by manufacturing? Manufacturing is basically a value addition process, a process of addition of value. So, value addition process. Now, I shall just explain with the help of a very simple example. Just imagine a lump of iron, maybe say half kg weight. What is the use of it? It has got neither shape, no size, no geometry, and surface is so poor, even the burglars will not lift it, they will hesitate. All right. So, it has got no value, it will not be sold even in 1 rupee. Maximum you can use it for as a paperweight or for throwing on somebody's head for protection, that much. Beyond that it has got no use. But friend, if from the same say mild steel, a piece of mild steel, from here what is this? Everybody knows, you understand, this is a bolt. Now, this bolt has got very much use in many places, it has got values, it has got utility. Why? Because it has got not only the desired material properties like strength, but also the appropriate geometry, that is size and shape, dimensional accuracies, and the surface quality or the features for which it is really a bolt, which can be used for fastening. It has got utility, so it has got value. When the raw material, which was heavier and bigger than the swan, the bolt, which had no value, maybe even 1 rupee or less than 1 rupee, because it had no utility. So, this is the raw material. And this is the product. This is the product which has got value. Now, here, so what is being done? So, what is manufacturing? So, manufacturing is a process of conversion of a raw material of low utility and almost no value, because of having no particular dimension, shape, size characteristics, into a product of high utility and value, because of having appropriate size, shape, feature, configuration, dimensional accuracies and finish. So, this is called manufacturing. By dint of that, what we are doing? We are adding value. As a result, we get the product. Therefore, manufacturing really means a process of value addition. Simple another example, analogy. You are the students, undergraduate students. What is the value? What is the utility of yourself? You are neither, you have got no professional knowledge, you have got little background knowledge. It is a good material, maybe like steel. You have got say some knowledge through school and higher secondary, but do you have any professional knowledge? So, what is the utility of you? You are not useful now. You have got no knowledge, no experience, no competence, nothing. But through this 4 years course, you will become engineer. Presently, as a raw material, what is the value you have? Minus 6,000 to minus 10,000 rupees per month. But after 4 years, when you become engineer, your value will be from 20,000 to 30,000 rupees per month. So, the 4 years program is nothing but a conversion process, conversion of a student into an engineer. You are the raw material, becoming a product like an engineer with full knowledge, experience and confidence and competence. And what is this institutes? It is a machine, and the learning process is a manufacturing process. So, this is a good analogy. Now, production engineering has got two pillars on which it stands. One is production process or processes. Other one is production management. Production management. Now, this production processes really means what we are interested of, manufacturing. That means manufacturing deals with production processes. Now, let me go to a little more detail. Say manufacturing. It refers to what? It refers to science and technology for producing objects then you should keep in mind while doing so, this has to be done effectively. Number 1, effectively, efficiently and economically. effectively means you have to get the work done according to the desired dimensions, finish and so on. Efficiently, the same work has to be done quickly with a less effort and less damage, and economically with a minimum expenses. But how this can be achieved? This can be achieved through number 1, proper selection and application of existing processes and systems. Manufacturing processes and systems, you have to use that. Second, proper selection and use of, because there are plenty of tools, materials, environments, machines, you have to choose appropriately. Proper selection and use of materials, tools, machines, environments, etc. Third, improvement of existing materials and processes. There are enough scope always to improvise these existing methods. And last, the development of new materials, processes, machines, techniques, maybe conventional or special, etc. But whenever you do this thing, development of new materials, processes, machines and techniques, one thing you should always keep in mind: whatever you produce, you think of is not useful. While doing so, you must remember that all these things should be technologically acceptable. The new material, the new technology, the new process, new system, whatever you do, that must be technologically acceptable. It should not be abstract kind of thing, it must be real. Second, technical feasibility. Many things may be technologically acceptable by science and technology, but technically may be difficult because of non availability. Technically feasible. Suppose you want to do something in a very ideal way, but the system is not available to you. So, whatever facilities you have to select the optimum one out of that. So, this is technical feasibility. Third is economically viable. You develop something new material, say like gold or say diamond all the time, that may work better, but what about the cost? Tremendous. So, you should always keep in mind that whatever you develop, that must be economically viable. The extra profit or gain it will earn must be more than extra effort or investment you make. That is called economic viability. And last but not the least, you should never forget that environment friendliness. Or it should be environmental friendly. It should not create hazards or pollution of the environment. You know, this has become mandatory all over the world. Even in our country, more than few thousand industries have already been closed down in Delhi, in many cities of the country, only because they are not fulfilling the requirements regarding environment friendliness. They are creating a lot of pollutions of the environment, air, soil, river water, sea water, and so on. So, this has to be taken care of. Now, friend, what is the present status of manufacturing globally? Now, the status is the science and technology of manufacturing is growing very fast in an accelerated rate, not at a constant velocity, very fast to meet the growing or increasing demands or challenges for number 1, increase in productivity, quality and economy. So, this has to be increased, quality has to be improved and economy has to be improved. Second is ultra precision Now, this manufacturing technology has gone to that extent so far that we can produce in the accuracy or finish in the order of ultra precision in the order of micron or submicron or nanometer also. And next is micro, even nano manufacturing, like say for example, even a small, think of a small robot with 6 degrees of freedom has to be developed. It should be so small in size that it can be put into the vein or artery through a syringe, and this will go into the through the vein and artery up to the say head or say brain or say heart, where this will do some inspection as well as surgery. Now, what are the components? What are the components of that small robot that has to be manufactured? So, we have gone to that extent, micro and nano manufacturing. Another point, as I said, that science and technology are growing very, very fast. It is very difficult to cope up with, and along with that new kinds of materials are coming up, which are very, very difficult to process, like forging, casting, machining, very difficult, and these are called exotic materials. Processing of exotic materials, which are coming up regularly with the progress of science and technology, like say nuclear science, aerospace and so on. But what about this exotic? What do you mean by this? As I already said, that which is very difficult to process, forging, casting, or maybe for example say titanium alloy, super alloy, let us say nickel based super alloy, inconel, mnemonic, then composites, ceramics, these are all exotic materials. These are coming up and getting widely used in the modern science and technology, but the manufacturing scientists and technologists have to develop in parallel processes by which such exotic materials can be comfortably and economically processed. Now, on the other hand, this is about the manufacturing. Next come to production management. Though it is not our subject at this moment, but you should understand that what is basically the role of management, production management in the industry. The role of production management is to make the overall plan of the manufacturing. Manufacturing does not mean a machine and a job and an operator. Manufacturing means a factory, people, organization, structure, machineries, working people, management people, then offices like sale, then purchase and various things. All these things have to be planned in advance. All these things have to be properly scheduled and programmed, coordinated, then controlled, monitored and finally optimized. All these things, all these activities are under the purview of production management. So, the production management will do all sorts of activities related to manufacturing for they should optimize, they should not only do that, they will do those work in optimum way for maximization or yes for say maximization of benefit, mostly benefit in terms of money, the profit and satisfaction to the customers. But while doing so, they should always keep in mind that they will do it with the best utilization of the resources, with the best utilization of the resources. So, what are those resources? With the best utilization of resources. Now, what are the resources? Number one, by resource we mean that man, machine, material and money. 4 M's. These are the first primary resources. Now, next resources, knowledge or expertise available, the resourceful people, and then the people, their vast experience, their creativity, yes, creativity or ability, intellectual ability or the creativity or the creative minds. These are the basic resources which have to be exploited to the maximum extent to earn maximum benefit and provide maximum satisfaction to the customers by planning, organizing, coordinating, monitoring, controlling and optimizing the resources. For example, let us take an example. Say this is a raw material. Say raw material. This has to be a lump of iron, maybe. This has to be converted into a product. Into a product. So, this is a conversion, this has to be converted. from low utility to high utility, from low quality to high quality, from low value to high value. So, this is the manufacturing process, it has to be converted. But friend, why you are going from say Kharagpur to Calcutta? It is not that you have to go by train all the time, you can go by road also. Similarly, within a city you can travel from one place to another place by train, by air, by other transports, there may be various methods. Similarly, the conversion of raw material from one raw material into a product can be possible in number of routes or number of processes, maybe casting, maybe forging, maybe rolling, there may be other routes also. Now, when there is only one option, there is no problem, but when there are so many options, the problem arises. Which one has to be selected? We have to select the optimum one. Which one is the optimum? How shall we decide? This will be decided based on the objective. What is the objective? The objectives is say manufacturing time of production. So, this has to be minimized, reduced. Then production, productivity or production rate, say P, this has to be enhanced. Cost, manufacturing cost, this has to be reduced as far as possible. Profit, say PR, this has to be increased. Now, simply increasing profit is not enough. What is more important? Profit rate. If you make a profit of 20,000 rupees in 1 year, that is not enough, but if you can make profit of 500 rupees per hour, that is more significant. Profit rate, say PR, this is basically profit divided by time, and this has to be maximum. So, either one or some of the objectives have to be fulfilled while selecting the routes or optimization. Now, all these things should be decided or under the jurisdiction of management. It is an example. Now, now classification. Classification of manufacturing process. How many processes exist? Nobody can tell correctly. Nobody can tell correctly anytime, because the number is so large and it is increasing so fast at any part of the world. It is very difficult for any person to keep the track. Say from this chair, I do not know that what new process has been developed in Japan or Germany right now within last 2 hours. It is impossible. It can be 1,000 processes. Then what is the solution? How shall we classify? So, instead of saying classification, we should say broad classification. So, all these processes can be broadly classified into some groups of certain features or characteristics. Now, I shall show you say shaping, number A, the first category. Shaping or forming, this is also called forming. Suppose there is a product, a metallic product, maybe brass. This has to be produced with a proper dimension as far as possible. Now, how this can be done? By shaping or forming. Say, first method, from solid, blank, you take a solid blank, a rod or something, and then this will be converted into this. Now, this can be done by forging, rolling, extrusion, then drawing, and so on. There are so many methods. These are all forming. Second is from liquid. You take the raw material in the form of liquid to get this product, all right. Now, here you can understand this is casting, Third is a removal process, sorry, not removal process, from powder. Using powder as raw material, this product has to be produced. So, what is the technique? This will be powder metallurgical process, simply PM is a powder metallurgical process. So, this is one group, shaping and forming. Now, next B is joining process, joining. Say a product has to be made like this, a big part with a small part as a protrusion, or say a joint, a T joint, like this, T joint of two steel plates. Here, doing these things by other processes will be uneconomic, will take more time and wastage of time and effort. So, this can be done by making this piece separately, this piece separately, this part separately, and you make this part separately, and then you join them simply. And what is joining processes? Welding, brazing, soldering. There are other methods also like adhesive joining and other methods. So, this is the joining process. Now, C, removal process. This is actually machining. Suppose you want to produce a product like this, a rod with two steps, one larger diameter and one small diameter, and this finish will be perfect, the dimensions will be uniform and to the correct values and so on. So, how do you get it? So, first what is done? A blank is prepared, a rod is prepared approximately to the dimension, and this can be done by forging, by casting, that is the preforming process, but that will not give the appropriate dimensions. Then what you do? You remove this material first, you remove this material, you remove this material from here, you remove this material, then you remove this material gradually, and then you remove this material. So, after removing the material from all around, what remains? The job with a perfect dimension and shape and surface finish. So, it is a gradual removal process of excess material from the preformed blank, and this is called removal process or machining. Now, another modern process, say D, is regenerative manufacturing. regenerative manufacturing. It is also known as rapid prototyping process. Rapid prototyping is one of the type of regenerative manufacturing. It is a very modern process and is very excellent process. It is very fast method, and it can be used for batch production or quick changeover from one design to another. So, a simple example. Here you see that suppose this is the product, this is the product which has to be made or manufactured, a solid body, a metal, say brass, and then first of all this job has to be drawn properly, not physically, but this has to be drawn in the computer by CAD, AutoCAD, or somehow it is called CAD model. So, you draw this thing in a computer, or you can get a solid job and then by probing or measuring the dimensions, you can put the store the data in a computer and then make this solid model. After this conceptual drawing, just imagine that you slice it, you slice layer by layer, just like this, layer by layer. So, what is happening? It is nothing but a sheet. So, it is a top sheet will have some hole, and this hole is continuous. So, each sheet will have some hole. Now, you make this first sheet. So, this is called slicing, but this is called virtual slicing. It is not really done. It is done virtually and through the computer and stored into the file, in each file. So, each file, one file corresponds to one slice, and this slice has to be manufactured separately. Suppose this slice is made, then you make the second slice, then you make the third slice. So, all these slices will be made by various methods, and then you just simply stack them and join them, you get the product. So, this is so quick. So, there is a prototyping. This can be made within 1 hour or 2 hours, but what are the processes? You see, this can be done in number of ways. Suppose this is the product, all right, a complicated product. This can be done with taking raw material in the form of liquid. If you take in the form of liquid, this is called stereolithographic method. You can start from powder or the selective sintering process. You can start from the foil, the loam, layered manufacturing by metal, and wear. You can use the wear as a source of material, and using the FDM process you can gradually produce it. Now, next is machining. Now, let us come to machining. Machining is also a kind of manufacturing process. For example, say here is a product. So, this is a preformed blank produced by casting or forging and somehow like this, and then you produce, you want a job of this shape, all right. Now, machining means conversion of the raw material, this is the raw material, into the product by removing the excess material, gradually in the form of chips, and then you get the product. Actually, in any manufacturing process, what are the steps, major steps? Major steps are preforming, like casting, forging, rolling, but these processes never impart the desired dimensional accuracy and finish. So, it has to be subjected to finishing, to appropriate dimensions and surface quality, and this is called machining. The finishing or semi finishing to a product of good dimension and finish has to be done, and after that, if necessary, this will be subjected to say heat treatment, maybe super finishing by grinding, honing, lapping and so on, but semi finishing and finishing may be accomplished by what is called machining. It is essential for what? Why? Why it is necessary machining? As I said that by preforming what we produce does not possess the desired dimensional accuracy and finish, for which they cannot serve the purpose. Suppose you want to have a bearing. This bearing has to be mounted on a shaft. So, the bearing has to be perfect dimensions, but by preforming, by casting forging, you cannot get it. This has to be finished by machining to appropriate dimensions and finish. Why? The purpose to enable the product, with the purpose of machining to enable the finished product fulfill the functional requirement. Functional requirement in for this example here fitting the bearing onto the shaft, that is the functional requirement. Next one is good performance or improvement of performance. More and more finished the product will be made, it will perform much better, and to enable survive longer or provide service, longer service or survive longer. So, machining is essential to impart functional ability to the product, then good performance of the product and prolonged service life of the product. Now, what is the principle? Now, what is the principle of machining? For example, say this is a plate. This is the plate, all right. Now, you see all the dimensions are not perfect, the surfaces are not flat, and now what you have to do that this top surface has to be flat and smooth, and that has to be done by removing the top layer by machining, and this layer will be removed strip by strip, one strip, then another strip, then another strip. So, by number of strips gradually the top layer will be removed. Say if I see from the front view, then this is the top surface and this is the product. Now, this layer has to be removed to produce a flat surface, all right. Now, this can be done if you put by chiseling operation. Suppose you just chisel, then this material will be gradually removed in the form of chips. So, this layer of material will gradually get removed by this process, and this will be perfectly flat, and this is the finished surface. This is the direction of motion of the cutting tool, this is a cutting tool, and this is the layer going to remove, this is called chip. So, this is machining. Another example, say here is a rod, you want a product, a rod of perfect circularity, but the raw material is very bad. So, you put a cutting tool, then you rotate this blank, and then this excess material will be gradually removed in the form of chip. It is another example. Then say there is a rod, you have to, there is a rod and you have to finish to a proper dimensions. There is a rod, very irregular size and shape, but you have to produce a finished surface, good finished surface. This will require a cutting tool. This the job has to be rotated, called cutting motion. The tool has to be moved in this direction, called feed motion, and this is called depth of cut, T, or depth of cut. So, you are producing a rod of a good dimension, straightness, etc., from a raw material. By removing the excess material here, this excess material in the form of chip. Now, the machining requirements. What is requirement to accomplish machining? For machining, the machining requirement to complete a job, some machining process is required. To accomplish the machining process, what we need? A machine, say machine tool, lathe or milling machine. Next, we need the fixtures, the job holding devices, the chuck or the tool holder, tool post to hold this job and tool firmly. Then we need a blank or raw material to be machined. If you do all work and forget to mount the job or the blank, nothing will happen. Next comes the cutting tools that have to be fitted. Power, the machine has to be put on with the power. Then environment, if necessary, apply cutting fluid for cooling and lubrication, you get the product. But whatever is produced may not be a product, it may lack quality and productivity. If you are not satisfied, then analyze what is the reason. If satisfied, okay. If you are not satisfied, then you analyze what is the reason. Analyze, identify the causes, and after identifying the causes, you take some corrective measure. If they say the tool has to be changed or the environment has to be adopted or changed, or the blank has to be changed, the machine has to be reconditioned, or fixture has to be reconditioned. So, these are the essential requirements for machining work. Now, what is now, the definition of machining? Machining is an essential process of finishing by which jobs of desired dimensions and surface finish are produced by gradually removing the excess material from the preformed blank in the form of chips with the help of cutting tools moved past the work surface. So, the essential features of this process is the dimensions, good dimensions and surface finish. By removing the excess material in the form of chips with the help of cutting tool. Now, what is machine tool? This work has to be done in machine tool. The machine tool is a device in which the job and tool have to be firmly held. The motion and power have to be transmitted from the source of power to the tool and job. Then control of the speed, feed and depth of cut. These are the major activities of the device called machine tool. But what is a machine tool? Definition: a machine tool is a non-portable, power operated and reasonably valued device or system of devices in which energy is expended to produce jobs of desired size, shape and surface finish. By removing excess material, it is just like machining, from the preformed blanks in the form of chips with the help of cutting tools moved past the work. So, the bottom part is purely machining. So, machine tool is a device of non-portable, power operated, reasonably valued, where machining activity will be accomplished. Thank you. Friends, our subject is manufacturing processes 2 and we are continuing module 1, classification of metal removal processes and machine tools, and this is the second lecture under the module 1, and the content or instructional objectives of this lecture 2 are: state the working principles of machine tools, the basic principles. Under that, illustrate the concept of generatrix and directrix, demonstrate tool work motions, give idea about machine tool drives. B, show configurations of machine tools and state their uses. C, state how machine tools are specified, the conventional machine tools, center lathe, drilling machines, milling machines, shaping machine and planing machines. And last, D, classify machine tools with examples. Now, say A, the working principles of machine tools. I remind you, machine tools, they produce geometrical surfaces. This was mentioned in the previous class also. Now, when you say geometrical surfaces, we mean flat surfaces, cylindrical surfaces and contour surfaces which can be mathematically expressed and redrawn according to program. Only those will be called geometrical surfaces. Now, major functional components of machine tools. A machine tool is comprised, all machine tools will be comprised of some common features, which are devices for holding the job and the tool. For example, in lathe, the jobs are held in chuck or the driving plate. Tool is a tool holder or tool post. Next, drives. All machine tools require power drive for moving the tool and the job. Now, the kinematic systems mean a chain of mechanisms to transmit motion and power from the source, that is motor, to the tool and job, and these mechanisms comprising the kinetic motion system can be belt pulley system, can be chain and sprocket, can be gears, worm and worm wheel, ratchet, pawl and rack pinion and so on. Next is automation and control system. Some machine tools are semi-automatic or automatic, so some automatic features are there, and control system to control the process parameters, speed, feed, depth of cut, etc.